Our target for today is I will be able to graph a step function within contextual problems. So as a class opener, I want you to define the function you see on the screen. So given the graph, write the following definition. So please pause now. Hopefully you identified that this piecewise function has three different parts. The first part would be a horizontal line with the equation y is equal to 1. It has a restricted domain in between 0 and 1. It includes 0, but it doesn't include 1. The next one will be y is equal to 2. It also has a restricted domain between 1 and 2, including 1 but not including 2. And the third one is y is equal to 3, with a restricted domain between 2 and 3, including 2 but not including 3. So this is what the definition of this graph should look like. This graph is actually part of our target today. You'll notice that it looks like a set of stairs. Therefore, we call this the step function. A step function has a constant value over each part of its domain. However, we want to remember that a piecewise function is still a function and it must pass the vertical line test. So therefore, we must be careful when we use the inequality signs. So if we look at the function in front of us, you'll notice in my red line, the function passes the vertical line test, and then it looks like it doesn't pass it at this point, x is equal to 1. However, you'll notice there's a point and a hole. That means that this function is defined at x equal to 1 at the value of 2. So there's no overlap. Again, crosses once, run into another situation with a point and a hole. It is defined at x equal to 2. The value is going to be 3, so there's no overlap. Now let's look at a real-world situation. An automotive repair center charges $50 for any part of the first hour of labor and $35 for any part of each additional hour. Draw a graph that represents the situation. Write the definition. So, one of the first things we want to do is we want to pull out the important information. Time, we're going to have represented by t in hours, is going to be our input, or our independent variable. C of t is going to be the cost as a function of time in dollars. Take a moment and copy this graph off the screen so we can move on with graphing this together. So let's go ahead and graph this information together. At first, if you walk into the shop, you automatically get charged $50 for any kind of service. Now at time 0, there's going to be an open hole because we haven't done anything yet. But in between 0 and 1 hours, so anywhere in between a half hour, 45 minutes, we're going to see that our function works until we get to that first hour. And that's going to stop. So this line represents the $50 for the first hour. Then we're going to continue with our staircase. If we look at the second hour, as soon as we go over 1 hour, then we fall into the next step. So we'd be charged the extra $35 an hour, therefore $85. It includes the 2 hours, but as soon as we go over 2 hours, it could be 2 hours and 1 minute, we have to add another $35, $120. And that ends. And you'll notice the pattern here. We're just adding 35 to each one. And each little step is the same with an open circle and a closed circle. So if we continue doing this, we're going to graph the point 3, 155 with a circle, 4, 155, everything in between, and so on and so forth. So our final graph is going to look something like this. Now obviously this does not stop. This will keep on going. I've run out of space on my graph, but we have to remember the staircase is going to keep on going. Hopefully our car won't be in the repair shop for that long. Now that we've graphed our function, we can talk about the definition. So writing the definition, our first step in our staircase was 50. We know it's in between 0 and 1 hours. And we add 35, we get 85. We add 35, we get 120. We add another 35, 155, and so on and so forth. And I'm going to put some dots at the end here to represent that this will keep on going. So hopefully today you feel that if you were giving a real world problem, that you'd be able to graph step function and go one step further and define it using function notation.